Hello everyone, welcome to my class. This is my today's second live class. Those who are not watched thermodynamics MCQ question, please watch that class also. There I discussed important MCQ question based on the topic thermodynamics. Then now structure of atom. Here I am going to discuss few MCQ question based on the topic structure of atom. Chemistry topic, very interesting and also easy topic. Let us start the class. Let us discuss the question here. Chemistry topic, very interesting and also easy topic. Okay, first question. The energy of an electron in an hydrogen atom in the ground state is 13.6 electron volt. Which one of the following represent the energy in the first excited state? Here they are given three different answers. Let us discuss. Let us discuss what is meant by Bohr model, what is meant by energy status, in everything in detail. Fastly I will explain. First one is Bohr atomic model. The electron revolve around the nucleus in a circular orbit with discrete energy level. That energy is quantized. Everyone you know the postulates of Bohr atomic model. Bohr he discovered, otherwise Bohr postulates electrons they will be around the nucleus, then they will be revolving around the nucleus in the circular orbit with discrete energy levels. That energy level is always quantized. The radius of the orbit is also a fixed. The electrons are supplied with energy, they jump to higher energy level. See here, if the electrons, if they want to go from one energy level to higher energy level, always they need energy. They will absorb the energy when they will jump. Otherwise, when they have to go to the higher energy level. The angular momentum of an electron is quantized. It is given by mvr is it will be equal to nh divided by 2 pi. This formula you have to remember. nvr it will be equal to nh divided by 2 pi. The frequency of light is mu is required to transition of an electron that differs in energy. Delta is delta E it will be equal to delta E divided by h mu h mu, two different energy levels divided by h is the energy of IL and lower energy orbitals respectively. This is the Bohr model. The energy of an electron in stationary orbit is given by En, it will be equal to minus RH z square divided by n square. When expressed in electron volt, the energy of an electron in an orbit is given by En, it will be minus 13.6 z square divided by n square electron volt. Here z is equal to 1, n is equal to 1, then E it will be minus 13.6 electron volt. When the atom is excited to first excited state, then n it will become 2. Then the energy it will be equal to E it will be equal to minus 13.6 1 square divided by 2 square. Z is equal to 1, then n it will be 2, then 1 square divided by 2 square is nothing but 2 square means 4, minus 13.6 divided by 4 is nothing but minus 3.4 electron volt. Hence the energy of an electron in a hydrogen atom in the ground state is minus 13.6 electron volt is minus 3.4 electron volt. Therefore the correct answer for this question is minus 3.4 electron volt. Simply you have to remember the formula, this one. In this formula you have to remember En it will be minus 13.6 z square divided by n square electron volt. In the hydrogen the z it will be the z value it will be 1, atomic number is 1, then n it will become 2, first energy level to higher energy level, first energy level to second energy level, therefore n value it will be 2. Let us move to the next question. How many maximum electrons can be present in an orbit? How many electrons, maximum number of electrons in an orbit? First option is 2, second option is 1, third option is 3, fourth option is more than one of the above. The correct answer, it will be 2. Maximum number of electron in an orbit, it will be always 2. Let us consider an atom is defined as the smallest unit of matter. It consists of subatomic particles are proton, positively charged, neutrons, neutral, electrons, it will be negatively charged particles. The nucleus of the core of an atom is populated by the proton and the nucleons. These two subatomic particles collectively determine the mass of the atom. In the nucleus, number of protons, neutrons combined we will consider as a nucleons. Then electrons, they will be evenly they will be revolve around the nucleus. Each shell consists of definite number of subshells determine the maximum number of electrons that can be found in that shell. Consider here 2s, the maximum number of orbitals is 1. 2p, you are having 3 subshells, and at a time the number of orbitals they can occupy maximum only 2 number of electrons, whether it may be p shell, s shell, like that, but maximum they can occupy at a time 2 electrons. There are primarily 4 subshells sbdf. Then S has a single orbit. P, yes, you are having 3 orbits are there. In D, 5 orbits. F, 7 orbits. The electrons in this orbits filled according to the rule, namely Hund's rule and Hofmann's rule. Each orbit has a maximum number of 2 electrons. Even the S orbit, it is having one single orbit. Then P 3, then D 1 2 3 4 5, then F 1 2 3 4 5 6 7. But all the orbit maximum number of electrons they can occupy in each orbit, they will be 2 only, not more than 2 they can't even occupy. That one only we are discussing in the question. Maximum only 2 electrons. The 2 electrons in our orbit have opposite spins. Yes, I am writing like this in opposite direction because they will be in opposite spin. What is meant by Hofmann principle, Hund's rule? Let us consider in detail here. Hofmann principle, according to this principle, the orbitals are filled in ascending order energy. The orbital with the lowest energy is filled first, the lower value of n, the lower energy level. Always when you are filling the electrons, always you have to fill the orbit having the lower energy. You have to fill the orbit having lowest energy. Next one, Hund's rule. According to this rule, the electron first occupies singly occupied orbital, then the second electron is added. This is because a singly occupied is more stable than a doubly occupied orbit, as the former is free from their interelectronic repulsion. Always Hofmann principle is telling the orbital having less energy, they will fill first. Then Next one, Hund's rule, always in an orbit, single electrons it will be filled, then followed by double electrons, because electrons they will be in opposite spin. To avoid the opposite spin repulsion, attraction, opposite spin normally they will attract. We will use the, when they will attract each other, when they will become a pair of electrons, then removing that pair of electrons we need extra energy. To avoid that one, normally according to Hund's rule, the single electrons we will filled in a orbital followed by the second electron. Yes, next question. A gas can be best liquefied by dash: increasing the pressure and lowering the temperature. Second option, increasing the pressure. Third option, lowering the temperature. Fourth option, more than one of the above. A gas can be liquefied by increasing the pressure and lowering the temperature. The gas can be best liquefied by increasing the pressure, lowering the temperature. If you want to convert gas into a liquid, okay, then you have to increase the pressure and also you have to lower the temperature. What is meant by liquefaction of a gas is a process by which the substance in their gaseous state are converted into liquid state. A gas can be best liquefied by increasing the pressure and lowering the temperature so that particles come closer. Change of state may take place very easily. Okay, then next, which of the following set of quantum number is not possible? Let us study in detail what is meant by quantum number. What is the help of the quantum number? This topic what I am discussing, structure of atom, is very important topic, and based on this topic also definitely they will ask the questions. The three coordinate that come from Schrodinger's wave equations are the principal, angular and magnetic quantum number. Three types of quantum numbers are there: principal, angular, magnetic quantum number. First, let us consider the principal quantum number. What it will describe? It will describe the size of the orbital. What is the size of the orbital? It will described by principal quantum number. Remember, if the orbitals which n is equal to 2 are larger than those which n is equal to 1, for example, because they have opposite electrical charges, electrons are attracted to the nucleus of the atom. Energy must be therefore be absorbed to excite an electron from orbital in which the electron is close to the nucleus, n is equal to 1, into an orbit in which it is further from the nucleus, n it will be 2. The principal quantum number therefore indirectly describes the energy of the orbital, even size of the orbitals. Here what they are telling, consider this is the nucleus, then this is the first orbit, consider this is the second orbit. If one electron, let us draw the nucleus in the closed one, okay, then this is the first energy level, this is the second energy level. Consider this is n is equal to 1, then this is n is equal to 2. If electron want to jump from first energy level to higher energy level, if the electrons jump from one energy level to higher energy level, then size of the atom it will be increases. Okay, then here, then also you can conclude the principal quantum number, it will describe the size of the orbital. Next, one more I will write, this is first energy level, this is second energy level, this is the third energy level. If the electron, if it is going to jump from second energy level to third energy level, here the size of the atom it will be still increased. Size of the atom is nothing but from the distance between the nucleus to the outer shell, outer orbit, we will consider as a size of an orbit. When size of the orbit it will be increases, otherwise number of orbit it will be increases, then size of the atom also it will be going to increase. Therefore principal quantum number it will describe the size of the orbital based on the energy levels. That also very very important, you have to remember. Next one, angular quantum number, it will describes the shape of the orbit. Orbit have the shape that are best described as a spherical if L is equal to 0, polar if L is equal to 1, clover leaf if it will be L it will be leaf. Very important point. Angular quantum number it will describe the shape of the orbital. In the exam they may ask L it will be 0, then the shape of the orbit it will be spherical. You have to remember L is equal to 1, then the shape of the orbit it will be polar. Then L is it will be 2, then the shape of the orbit it will be clover leaf. They can even take more complex shapes as the value of the angular quantum number become larger. There is only one way in which the sphere L it will be 0 can be oriented in space. Orbital that have polar clover leaf shapes however can point in the different direction. Therefore D, a third quantum number known as magnetic quantum number, to describe the orientation in space of a particular orbit. The third one, magnetic quantum number, it will tell the orientation of a, otherwise the orientation of orbits in the space. Orientation in space, how the orbits they will get arranged in the space. It is called the magnetic quantum number because of effect of different orientation of orbitals was first observed in the presence of magnetic field. Then next one, rules, the three quantum numbers n, l, m that describe the orbitals are integers of 0, 1, 2, 3 up to etc. Principal quantum number cannot be 0. N cannot be 0. N need not be 0, cannot be 0. N it will start from 1, 2 like that, 3 like that. Allowed values of n are 1, 2, 3, 4 like that, so on. For angular quantum number L, it may be 0. Between 0 and n it will be 1. If n is n, it will be 3. For example, L can be 0, 1, 2. Magnetic quantum number can be any integers between -1 and +1. If L is equal to 2, M can be neither -2, -1, 0, +1, +1 or +2. Hence, n is equal to 3, L is equal to 3, M it will be -2, M it will be plus or minus 1 by 2, which is not possible according to my explanation. Therefore, which one is not possible here? Option 1 is not possible here. This is the which set of quantum number is not possible, they are asking. This one is not possible. N is equal to 3, L is equal to 3, M it will be -2, ms plus of this set of quantum numbers are not possible. Next. Next question. Next question, which of the following elements is the most electronegative? First option is aluminum, second one is boron, third one is gallium, fourth one is more than one of the above. Boron. Which of the following element is the most electronegative is boron. Let us consider how. What is meant by an electronegativity? Electronegativity is defined as the property of an atom to attract the shared pair of electrons towards itself. The electronegativity is nothing but the property of an electron to attract a shared pair of electron towards itself. Fluorine is the most electronegative element in the periodic table. It depends on the size of an atom in the given list of elements. Boron has the smallest size. As the size of an atom increases, the distance of electron from the nucleus increases, the electronegativity it will be decreases. As the size of an atom increases, see here, this is an atom, this is the nucleus, this is the orbit, first orbit, second orbit, third orbit, like this. Then this is the fourth orbit. Sorry, I am not able to draw properly. Here, see here, compared to this last orbit, here you are having an electron like this. Then here, the distance between the electron and nucleus is far. Therefore, easily you can take this electron very easily, because the this electron is far from the nucleus, the force of attraction is less, easily you can remove this electron easily. That's why the electronegativity it will be mainly depends upon the size of the atom. Electronegativity is defined as the property of an atom to attract a shared pair of electrons towards itself. Fluorine is the most electronegative element in the periodic table because the fluorine, then it is depend on the size of the atom. In the given list of element, boron has the smallest size. As the size of atom increases, the distance of electron from the nucleus it will be increases. Then easily you can remove the electron. Therefore, electronegativity it will be decreases. whatever the energy you are spending to remove an electron, that energy it will be decreases, therefore electronegativity it will be decreases. Fluorine is the most electronegative element because of the small size of the fluorine, the electrons is very close, it is very near to the nucleus. To remove that electron in the fluorine, you need to spend more energy, therefore electronegativity it will be more. Remember that one very important point. The element having tetra atomicity is first option helium, second one is nitrogen, third one is phosphorus, fourth one is chlorine. Phosphorus, let us consider what is meant by atomicity. The present number of atoms in any molecule of an element is called atomicity. Atomicity is nothing but the present number of atoms, how many number of atoms are present in a molecule, that one we will consider as atomicity. Tetraatomic molecules are those made up of 4 atoms. Phosphorus exists as a molecule made up of 4 atoms in a tetrahedral structure. Each phosphorus molecule consists of 4 atoms of phosphorus. Atomicity is nothing but the number of atoms present in a molecule. Phosphorus, the atomicity it will be 4, it will exist in tetrahedral structure, therefore it contains 4 atoms. Okay, next, atomicities of some elements I given the list here. Argon helium monoatomic, oxygen chlorine diatomic, nitrogen diatomic, phosphorus tetraatomic, sulfur polyatomic. Remember, very important question. Easy concept. Who coined the word atom? First option Democritus, second option Thomson, third option E. Rutherford, fourth option John Dalton. Who coined the word atom? Democritus. The word atom is coined by Democritus. He suggests that if we go on dividing matter at a certain point, the atom becomes indivisible, cannot be divided further. Yes, atom itself is the smallest unit. You can't divide the atom. He called these particles as atoms are indivisible. Then the scientist who discovered what? Thomson, he discovered electron. He Rutherford discovered alpha and beta particle. John Dalton, father of, we will consider John Dalton as the father of atomic theory. Remember. Next, alkali metals are assigned which group in the modern periodic table? First option second group, second option 18th group, third option third group, fourth option first group. Yes, alkali metals assigned in the modern periodic table, it will be first group. Yes, alkali metals, this one is the first group in the periodic table. This is first group in the periodic table. This is the modern periodic table. Remember where you will get, where the all the elements they are placed, you have to remember the periodic table. Then based on this they will ask more number of questions. First group, first elements in the periodic table are alkali metals. They have ns1 outermost configuration, belong to s block elements, and they also have a strong tendency to donate their valence electron in the outermost shell to form a strong ionic bond. Almost all alkali metals they are able to donate an electron, then they are able to form a strong ionic bond. It contains elements from lithium to francium. Next, to which block do the element with atomic number 56 belong to? Atomic number 56 belong to S block elements. Next, Yes, atomic number 56. Barium belongs to S block element. Barium, electronic configuration barium, xenon 6s2. Modern periodic table is classified in the following: P block, S block, D block, F block. S block element include alkali metal and alkaline earth metal. Remember, the maximum number of electrons that can be accommodate in M shell. How many number of electrons? 18. Easy question. Electron shell, also called a principal energy level, is the region where electrons revolve around the nucleus of an atom. The general formula for filling an electron, we will use the formula 2n square, where n is the number of the shell. When n is equal to 1, k shell, maximum number of electrons is 2. When shell is L, maximum number of electron is 8. M shell, maximum number of electrons 18. N 32, O 50, up to V K L M N, up to here we will use. This one is not there, this one we will not study in detail. KLML, normally we have this 4 type KLML. Who was the first to propose atomic theory? Who proposed the atomic theory first is John Dalton. Remember, see, name of the scientists, what they discovered. J.J. Thomson discovered electron subatomic particles of an atom. Rutherford, an atom is composed of an empty space, mostly with electrons orbiting in a set of predictable path around a fixed positive charge nucleus or proton and neutron. J.J. Thomson, he discovered electron and subatomic particles are there. Rutherford, he discovered the nucleus of an atom. Then the nucleus, it contains a neutron. Neutron is a combination of proton and neutron. He discovered. John Dalton, first to propose atomic theory. Neil Bohr, atomic structure, concept of energy of orbitals and quantum theory. Everything he explained by Neil Bohr. Remember this one, very very important. Who among the following discovered the neutrons? Who discovered the neutron? Chadwick. J. Chadwick. Remember. Yes. Discovered. J. Chadwick discovered neutron. Rutherford discovered proton. J.J. Thomson discovered electron. Eugen Goldstein, positively charged particles in the nucleus. What is common along lithium, sodium, and potassium? Which one is common? First option, these have one electron in their outermost shell. Second option, there are alkaline earth metals. Third option, these cannot form oxides. Fourth option, these are inert elements. Which one is common? They have one electron in the outermost shell. Lithium, sodium, in the outermost orbit, all they have only one electron. That is the common thing. Lithium, sodium, potassium has one electron in their outermost shell. Belong to group 1. They have alkali metals, not alkali earth metals. They have alkali metals. Lithium can form lithium oxide, sodium forms sodium oxide, potassium can form potassium peroxide in the presence of oxygen. These are not inert elements. Not inert elements. They react with other compounds. Inert elements means they will not react with any other element, but these are not inert, they can easily react with another element. Next, dash elements have the largest atom: fluorine, oxygen, hydrogen, lithium. Lithium is the largest atom. Largest atom is defined as its atomic radius. Distance between the nucleus and outermost orbit valence shell is more. As we move from left to right in the periodic table, atomic radius, it will be decreases. Left to right, atomic radius decreases, but we go from period, go down the period in the periodic table, atomic radius, it will be increases. Remember these 2 points. Hence, lithium has the largest atom. It is greater than hydrogen, oxygen, and also fluorine. Generally, the valency of electropositive element is, the correct answer it will be 1, 2, 3. The valency of electropositive element is 1, 2, 3. I think today I discussed few MCQ question based on the topic structure and atom. If possible, evening like night 9 or 10 o'clock, I will try to take a class cylinder, volume and surface area. Very important topic in maths. Okay, and now today onwards I will try to take the classes regularly. Please continuously watch my classes. Please support to my videos. Okay, thank you everyone. Thanks for listening my class. Take care.